before is really just 3 theorems. They're 3 shortcuts. So I want to make sure that we all understand what we've been doing. So first of all, the whole big idea up to this point has been, let's try to prove that 2 triangles are similar, so that the definition of similar polygons tells us if they're similar, then their angles are going to be what? Careful. Their angles are going to be what? Congruent. And their side lengths are going to be proportional. And so we've had to go through and take a picture and separate our triangles that are overlapping, and we had to prove that they were similar by side, 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 side angle, side, or angle, angle. And then after we could prove they were similar, we could write a proportion, cross multiply, and solve. Right? Everybody with me? That's what we've been doing. Okay, this section is going to let us skip the proving they're similar part. This section is going to give us 3 shortcuts if each of the things have something special in them that have to happen first. So if one of these special things is occurring, then you can use this shortcut, okay? And you won't have to prove the triangles are similar. So it's just basically 3 theorems. You won't really, well, I won't say that. Anyway, triangle proportionality theorem is our first theorem. The triangle proportionality theorem is going to start with the emphasis or the hypothesis that you have to have a line parallel to a side of the triangle. If the line is not marked parallel, you cannot assume it's parallel. It has to be parallel. Either you've got to have some information to prove the lines are parallel, or they have to mark that they're parallel. So in my picture, I can see that this line is parallel to this line, right? It doesn't have to be a full line. It could just be a line segment. But as long as you have a piece in your triangle parallel to another piece, then instead of having to prove these 2 separate triangles are similar, what this is going to say is that your piece that's parallel will divide the 2 sides proportionally. Meaning that AE over EB will now equal AF over FC. Or a quicker way to write it would be A over B is equal to C over D. Are you guys with me there? You don't have to separate the 2 triangles. You don't have to try to find all their side lengths. Here's the part that most students end up messing up on the test. It does not say that E over F is proportional to these fractions. E over F is not proportional to these fractions. These fractions are comparing a side of a triangle to a piece of a trapezoid. That fraction is not going to be the same as E over F, which is comparing the bases of the triangles. Are you with me? So this shortcut lets you compare the 2 pieces that are found when the line's parallel, but it does not let you compare the bases of the triangles to that. So be careful that you do not use E over F. If you're going to use E over F, then you have to redraw the little triangle and redraw the great big triangle so that you can compare E to F by comparing the side lengths. So this would be A. What would this be? A plus B. Okay, so if you want to compare the bases to the sides, you can do that. But you can't compare the bases to pieces of the sides. Is that really clear? I don't want you to miss that on the test, okay? So what you can do is you can compare these 2 sides. They're split proportionally. So when you look at the first example, you first have to see, do you have parallel lines? Again, if they're not parallel, you can't use this shortcut. If they're not parallel, you're going back to what we did before and you're redrawing the pictures as great, big, and small, and you're making sure they're similar and you're writing proportions. Are you clear? If the lines are parallel, then you can use the shortcut. This one wants me to find US. I can call it X. What would my proportion be using my shortcut since the lines are parallel? How could I write a proportion now using my shortcut? Go ahead. Who's talking to me? Go, Josh. X over, okay, I'm going to go do what you're saying. Go ahead, X over 4. Okay, that is going to be true, but because they're going to make us go back in a second and prove it, that way doesn't really prove it. So I'm going to stick to what they said. Instead of going X over 4 equals 14 over 10, they're going to say X over 14 is equal to 4 over 10. And your way will work just fine to solve for X. You can definitely set it up that way. You would still get the correct answer. But because I know where we're headed next, I'm going to have us switch it, okay? So X over 14 equals 4 over 10. Is everybody with me? If you have a parallel line, it divides the sides into 2 pieces, and those sides are proportional. X over 14 equals 4 over 10. Part over part equals part over part. But you cannot use the actual parallel lines, only the pieces. Okay? Cross multiply, we get 10x equals 56. Divide by 10, and what is x? 5.6, and that is the value of US. First shortcut. If 2 lines are parallel in a triangle without separating them, we can say A over B equals C over D. Any questions on the first shortcut? Okay. Look at the second part in your notes. This is not a second shortcut. What is this? Converse. What does converse do? Say it again. Flips it. It switches it. Instead of saying if the lines are parallel, then the sides are proportional, it's going to say if a line splits the sides so that they're proportional, then the lines must be parallel. So they're going to ask you to prove that the lines are parallel. Not as a proof, but basically just verify, show, or explain. So if I look, and again, this is called the converse of the triangle proportionality theorem. If I look at this next example, when you look at the picture, does it show you that the lines are parallel? No. They want you to verify that the lines are parallel. So you're just going to show your work, but this is where I was explaining to Josh a second ago. To prove it, you've got to do part over part and then move to the next side, part over part. So which sides could I compare here? So I'm going to do BD over DA, which is 15 over 10. And then I'm going to check CE over EA, which is 12 over 8. And I'm trying to see, are these proportional? Do they reduce to the same fraction? So again, it's part over part and part over part. Checking to see if those do reduce to the same fraction. What's 15 over 10? Okay, and let's leave it as a fraction. So that is 3 over 10. When we're talking about ratios and proportions, we want those to be in fraction form. So 3 over 2, what's 12 over 8? 3 over 2. And so do they reduce to the same fraction? Yes, and so that proves that DE is parallel to BC by the converse of the triangle proportionality theorem. So if they're parallel, part over part equals part over part. If they're not given to be parallel, but we're trying to prove it, we're checking to see if they reduce to the same fraction. And then we can use the converse of that theorem to prove that they are parallel. Any questions on the first theorem? Okay, second one, second shortcut. Second shortcut is called the two transversal proportionality. You're going to have two transversals. That's why it's called the two transversal proportionality theorem. The thing that has to be true for this to work is you have to have 3 or more parallel lines in your picture. 3 or more parallel lines. So when I look at this picture, they should have told you that these 3 lines are parallel. That's a typo, so please add those little parallel marks. So this shortcut says if you have this picture, then if in that picture you have 2 transversals. Remember, a transversal is just a line that intersects 2 or more other lines. So we have 2 transversals. If you have 3 parallel lines or more, and you have 2 transversals, the parallel lines are going to split the transversals into pieces. They're going to divide the transversals proportionally. So when I look at my transversal, notice I have 2 pieces here, AC and CE. Oops. Did it again. Sorry. AC and CE. Okay, if I look at the other transversal, what are my 2 pieces? BD and DF. So this theorem says that it will split each transversal proportionally, meaning AC over CE will equal BD over DF. I'll write it up here again and use some little simpler terms. Same idea. If I have 3 parallel lines cut by 2 transversals, then A over B should equal C over D. Is everybody okay with that? Again, it's the transversals that are being split proportionally, not the parallel lines. Example, take a minute, read this. What are they assuming is parallel in this picture? The trees. They're assuming that each of these trees are perpendicular to the ground, which would make them parallel to each other. In reality, they're probably not truly perpendicular to the ground, but we're going to pretend that they are. So here's all of our parallel lines. What are the transversals then? Which lines are the transversals? Talk to me. The dotted lines, okay? The lines that are intersecting those parallel lines. Okay, and they put all of this information already on the picture for you. They want you to find LM and MN. So remember, this theorem is saying that the transversals are split into pieces, and each of those pieces will be proportional to the other 2 pieces. So in our picture, that would mean AB over BC would be proportional to what? Okay, L over LM. Or AB over CD would be proportional to KL and MN. Or BC over CD would be proportional to LM over MN. So any of these 2 pieces will be proportional to any of the corresponding 2 pieces. Okay? So we want to write a proportion to find LM. I'm going to call that X. And then one to find MN, which I'm going to call Y. So somebody help me out. What would be a good proportion that would help us find X? Okay, again, I'm going to stick with the way they wrote it instead of the way you're saying, even though that's true. Instead of doing 2.6 over X, I'm going to do 2.6 over 4. If I use 4.1 and 2.6, then that's going to give me 2 unknowns down here. I can't have 2 different unknowns. So I don't want to use these 2 first, because then I have 2 unknowns. Let's just find x first. So 2.6 over 4.5, so I'm going to go from here to here, is equal to what? X over 4.9. Okay, so part over part of one transversal should equal part over part of the other transversal. Cross multiply. 4.5x equals what? Help me out with your calculators. What's 2.6 times 4.9? Thank you. 12.74. Divide by 4.5, and what do we get? Okay, what do the directions tell us to do? Round to the nearest tenth. So what does x become? 2.8. Somebody agree with Jedi? Okay, and what are my units? Inches. So my answer should actually be LM equals 2.8 inches. Should we use our rounded answer to find our next answer? No. You should only do that if it's the only option you have, and you shouldn't use the rounded value. You should use the whole value in your calculator. So instead of coming over here and using our value for x, let's don't use x, even though we know what it is now because it's rounded. Let's try to find y using the exact values that they gave us in our picture. So what would be a good proportion here that would help us find y? 4.1 over 4.5 is equal to y over 4.9. So we did the farthest one on the right here over the farthest one on the left equals the same thing, y over 4.9. Cross multiply. 4.5y is equal to, one more time, 20.09, and then divide by 4.5. What do we get? 4.5. Somebody agree with Jedi? Okay. And so that is MN equals 4.5 what? Inches. Questions on the second shortcut? Two transversals, proportionality theorem. Okay. Last theorem and shortcut. It's called the triangle angle bisector theorem. And it's called that because it's a triangle that has an angle that is being bisected, right? If you look at the picture, we have a triangle, and in that triangle we have this angle A, and it's being split into two congruent parts. So the triangle angle bisector theorem. So again, the first thing you have to have before you can use this theorem is you have to have a triangle that has an angle that's being bisected. If that's the case, then what this theorem says is the angle bisector will divide the opposite side into two pieces, and those two pieces will be proportional to the other two sides. So over here in the picture, that means the two pieces are BD and DC. Those will be proportional to AB and AC, the other two sides. Or using a little simpler over here, A over B will equal what? C over D. Now here's the most common mistake I see on this one. I have students who do this. A over B equals, and then they jump up here and go D over C. You will get it wrong if you do it that way. Wherever you start on the first fraction, you have to start on the second fraction. So if you start on the left, A over B, you have to start back at the left, C over D. Okay? Be careful. Don't just jump where your pencil was and jump up. That'll mess you up every time. Questions on this shortcut? Okay. Last example for 7-4 should be this example. What would be the proportion that we could write using this theorem? Awesome. Let's go with Hallie. Hallie, what proportion could I write using this theorem? Okay, and that will work, but again, I'm going to try to set it up the way the theorem did just to make sure everybody's with me. You could do x minus 2 over 32. If you do that, where would you start on the next fraction? And that would be fine. It'll work every time if that makes more sense to you. But what the theorem actually said was this piece is split into two parts, and they wrote them as a fraction. So they did x minus 2 over x plus 5 and set that equal to what? 32 over 40. And again, I'm going to emphasize what you said would work, and you are welcome to work it that way. All right, so cross multiply. Don't forget to distribute. 40 times x minus 2 equals 32 times x plus 5. Go ahead, solve that for x, and tell me what you get for x when you're finished. Christian, you okay? I'll give you about 30 more seconds, and I'm going to call on somebody to tell me what they got for x. Should not be rounding at all. There should be an exact value. So double check your work.
Oh, that's not good.
Double check your math. And if it was a decimal, you would never round. You would always give it to me in fraction form unless it says to round. He's asking you what you got for x. All right, Jackson, what did you get for x? For x, everybody got 30? Okay, distribute. So 40x minus 80 equals 32x plus 160. Subtract. JP, you see your mistake yet? Subtract 32x and you get 8x minus 80 equals 160. Add 80. We have 8x equals 240. So x is equal to 30. Anybody not get 30 still and not sure where we went wrong? Okay, is that our answer? No, be careful. Find PS and SR. So PS should equal 30 minus 2, which is 28. And SR should equal 30 plus 5, which is 35. So these are our two answers. Okay, I went pretty quick on 7-4. It is basically just three theorems. We had the triangle proportionality theorem and its converse, the two transversal theorem, and the triangle angle bisector theorem. Any questions on those three theorems before we move on to 7-5? Okay. So in 7-5, we are going to use this to talk about two different real-life situations where you might want to use similarity. The first way is if you want to have an indirect measurement. What is an indirect measurement? So basically, what we've been doing all semester long is indirect measurements. We have been using formulas to calculate the measurements on pictures without physically going and measuring the shape with a ruler, a protractor, a tape measure, whatever. So in real life, I'm sure this has happened to you, you're setting up on the third floor, staring out the window, looking at the flagpole outside, and you're thinking to yourself, how tall is that flagpole? All the time, right? And so you don't have a boom truck, you don't have a way to get up there to measure the height of that flagpole, so you think, I'm going to use indirect measurements and similarity. I'm going to figure out the height of that flagpole. Okay? So here's what you can do the next time it's a sunny day and you're bored. You can go stand outside next to that flagpole. And here's the flagpole. And the flagpole's going to have a shadow. When that sun, oops, that's terrible, sends the shadow from the flagpole, it's going to make a triangle. And what kind of triangle is this going to be? A right triangle. And if you stand next to that flagpole, you're going to have the same angle coming down from the sun. So these angles are going to be congruent. And you're going to make a right triangle. And you're going to have a shadow. Let me answer the phone. Mrs. Ashley? I thought I did. Did I not hit save? Okay, sorry. You bet. Thank you. Bye-bye.
See somebody like doing this.
Yeah.
Okay, so, sorry. So here we go. Back to our little experiment here. So when you're bored, you're going to go out there, you're going to measure your shadow, or have your friend, because if you try to measure your own shadow, that's not going to work, right? So have somebody come out there with you, measure your shadow. You can measure the flagpole shadow, and then you hopefully know your own height. So let's say, Brendan, how tall are you?
6'4".
6 foot, okay? So Brendan, I'm gonna say you're not really 6 foot and you're lying. This is 5'11", because I want it to be in different measurement, okay? So 5'11", Brendan's gonna measure his shadow. He knows his height. He's gonna measure the flagpole shadow. And what do we now know about these two triangles if they have a right angle and another congruent angle? They're similar by angle-angle similarity. So that means you should be able to write a proportion and compare them, right? The only problem we're going to have today is we can't have two different units of measure in our proportion. So we want to make sure, let me say that again. You can have two different units of measure in your proportion, but you can't have two different units of measure in one single measurement. So this triangle could be measured in one unit, and this triangle could be measured in a different unit, but you can't have this two different units on the same measurement. So we would have to say that Brendan is actually 71 inches tall, okay? Or we could say he's 5 and 11/12 feet, but we couldn't use 5 feet and 11 inches. Are you guys with me there? Okay, so you can measure objects out in the real world that you can't physically measure by using your geometry. And that's kind of one way that you might use it. Like I said, you're probably not really going to go out there, but hey, maybe you want to, and you will, and I'll see somebody out there measuring one day. So, vocabulary, indirect measurement, any method that uses a formula. So what we've been doing all year long. Similar figures and or proportions to measure an object. Okay? Whenever dimensions, I already said this, are given in both feet and inches, you have to convert them to one or the other. Most of the time, my students convert them to inches because they want to work with whole numbers and not fractions, but you can convert them to feet and work with fractions. That's up to you. Okay, here's our first example. Tyler, he's sitting up there on that third floor wondering what the height of the telephone pole is. He measures the pole shadow, his own shadow, and then made a diagram. We're trying to figure out what's the height of the telephone pole. Okay, what's the very first thing we're going to have to do for this problem? Convert. So let's do that right now. Let's go, Lily, you convert Tyler's height. Zach, you convert Tyler's shadow. Cammie, you convert the shadow of the telephone pole. Okay, and then I'm going to come around. You guys are going to tell me what you got. So So Lily, did you get the height for Tyler? How tall is he? 69 inches. Zach, let me know when you have the shadow. 92 inches. Cammie, let me know when you have the shadow for the pole. 460 inches. Okay, so we're going to convert. How did they get those? What did they multiply by? 12, and then they added in their inches. Everybody can convert, right? Okay, so now we want to write a proportion. So let's write our proportion. Martin, how would I set my proportion up? Okay, make sure you're with me. Everybody with Martin? Yes, it will not matter. You can do numerator over numerator, denominator over denominator. You could do, you could flip those over. So you could do 92 over 460 and 69 over h. All will still work out the same. As long as when you cross multiply your proportion, you're doing 92 times h, then you set your proportion up correctly. Okay, so we have 92h equals, help me out, what's 460 times 69? 31,740. And then we're going to divide that by 92. And the answer is 345 inches, right? We're still in inches, agreed? Because all of our measurements were in inches. Do you ever quote to someone that you are a certain number of inches? No. That's something mamas do when their babies are little. You don't do that when you get big. I mean, I don't walk around saying, yep, Brendan, he's 60 inches. He's 72 inches. That would be weird, okay? So here's my rule. Are you ready? I do not want you to give me an answer in just inches if the original problem was in feet and inches. I want your answer in feet and inches. So I'm going to make sure you know how to use your calculator correctly to do that. So I'm going to pull my calculator up and walk through it with you. Okay? Okay, so let's work together here. You guys got your calculator, I've got mine. What do we want to do to 345 to figure out? Divide by 12. And it tells me it's 28.75 what? Feet. Now, we don't want our answer in decimal feet. We want our answer in feet and inches. So that means I have 28 feet. And then how do I figure out how many inches I have? Okay, this one's easier because it is an exact value, 0.75, which we know is 3/4, which we know then 3/4 of 12 is 9. Okay, but the problem is these aren't always going to work out to be nice, pretty little 0.75, 0.5 kinds of numbers. So if this was something like 0.521369, the easiest way to do that on your calculator, so do it with me so you can practice, would be to get rid of the whole number. So what would we want to do to get rid of the 28? Subtract 28. And now we have the decimal part, because if it's a repeating or a long decimal, we want the whole decimal, so we'll just get rid of the whole number. And then what do we do if this is 0.75 of a foot? Multiply it by 12. And so notice we get a nice pretty 9 inches, but it might not be a nice pretty 9 inches on your homework. It might be 9.372. Then you'll just round to the nearest inch. So you would still, if it was 9.3, you would just say 9 inches. Okay? So we are going to put our answers, if they're given in feet and inches, we're going to put our answers back into feet and inches. And you have a calculator that you can use that will help you do that. Any questions? All right. Moving on. The next thing that you can use the idea of similarity for is if you want to create a scale drawing. That's why you have a ruler today. You are physically going to create scale drawings. Again, a blueprint is a perfect example of a scale drawing. So a scale drawing just simply represents an object as smaller or larger. This next statement will cost some of you points on the test if you're not paying attention right now. So make sure you're listening to me. We're going to talk about a scale. A scale is different than a similarity ratio. A scale can be measured in different units. A scale is something that is going to give us the ratio of the length of our drawing compared to the actual length of the object. So for example, a scale could be 1 centimeter to 1,500 meters. Notice the units are different. If you want the similarity ratio, you have to have the same units. And therefore the units cancel out. Because if you have something like 5 inches to 12 inches, that's just 5 to 12. Inches cancel out. Are you with me? Okay, so if I have a scale of 1 centimeter to 1,500 meters, how could we make that a similarity ratio? Okay, how many centimeters are in a meter? 100. So we would change meters to centimeters. So we would have 1 centimeter over, what is 1,500 times 100? 150,000. And it would be in centimeters. What's going to happen to the centimeters? They cancel. So our similarity ratio is not 1 to 1,500. Our similarity ratio is 1 to 150,000. Do you guys understand the difference between a similarity ratio and a scale factor? Similarity ratio, you have to have the same units. They cancel out. There's no units there. They could be anything at that point. It's 1 to 150,000. It could be 1 inch to 150,000 inches. 1 mile to 150,000 miles. So whatever the unit is, it's the same unit. The scale factor can be in different units. You with me, Yesenia? Stay with us. Okay, so I just wanted to make sure this was not in your notes, but this could affect you on the test, so I want to make sure that you're clear about that. What we're going to do next is we're going to make scale drawings. Remember that your proportion can compare different units as long as you have one unit per object. So you can have feet on one object and inches on another object. You just can't have feet and inches on the same object. So this is way back in the day, before we had a GPS on our phone where we could type in Madison to Wausau and it would tell us how many miles it is. Way back in the day, you had a road map on paper and you had a handy dandy ruler. And you took your little ruler and you went, okay, from Madison to Wausau, I'm going to measure that. And that is 11 1/8 inches. And your road map had a scale on it. And it said, for every inch, that's the same as 13 miles. And then you calculated how far is it then from Madison to Wausau, or however you say that. Okay, so that's what we're going to do. I know that today you probably would not do this. You would just grab your nice little GPS, type in your 2 locations, and boom, it tells you not only how far it is, how long it's going to take you to walk there, drive there, bicycle there, gives you all the information you need. But just in case you ever need to, my husband's a truck driver and he says your GPS fails you often. So he loves his little handy dandy road map. He likes to pull it out. He can figure out where he's going. He's old school. All right. So we're going to use our scale. The way you're going to work these problems as they get harder is you're going to write down your scale, and you're going to set your scale equal to your other fraction that you're looking for. So if they give you a problem like this, start with your scale. What's our scale? 1 inch to 13 miles. We know how many what? Inches it is to get from the one city to the other. So where's that going to go in our second fraction? On the top. Keep your inches in the same location. So we're going to put 11 1/8 inches on top. And Kristen wants to know how many what? Miles. So where's that going to go? bottom, X. Are you guys with me? So start with your scale and then use it to write another fraction to create a proportion. They give me the scale, they're going to give me one of those measurements, cross multiply and solve. Again, you get a calculator for most of this test. The bonus will be no calculator. But for the rest of the test, you'll get a calculator. So I want to remind you how you can use your handy little calculator there to help you out. So what do I need to do when I cross multiply here? What am I going to multiply? 13 times 11 and 1/8. Where can we type in 11 and 1/8 using my calculator? Alpha what? Y equals. And which one lets me type in a mixed number? 1 only lets me type in an improper fraction. 2 lets me type in a mixed number. So alpha, y equals, is this little button up here at the top. Yours may not have the y equals anymore. It may be rubbed off. But it's the first gray button at the top. Okay? So once you have alpha, y equals, then you can choose number 2. And it lets you type in a mixed number. So if you didn't know that was there, that's super helpful if you have to take an ACT time test. You can use that little button. And again, if you want to type in an improper fraction or just a regular fraction, use number 1. And then number 3 lets you toggle back and forth between the two. So we're going to type in 11. How do I get to the numerator? The little arrows flashing, so arrow to the right. And then I want 11 and 1. How do I get to the bottom? The little arrows flashing to the right. And then I'm going to type in 8. And again, the little arrows flashing, so I want to go to the right. Are we good? Times, what are we multiplying it by? 13. Oops. 13. Okay, and it gives us this ugly improper fraction. We don't want it in ugly improper fraction form. Yeah, the decimal form, okay? So anybody else has put theirs in fraction form like this? All right, so either way, we don't want a rounded answer. We could type it all out as if it's an exact decimal, or we could put this back in fraction form from either location. What do we do to get it put back into mixed number form? Okay, I could go through, I can't divide by 8. If I divide by 8, that's just going to give me 1,157. Oh, I see what you're saying. You're doing it by hand, Jedi. You're doing the right thing with your mind. I'm so sorry. You could by hand, but I'm trying to teach you how to use your calculator. You could do this, which is the smart way to work it. But I'm asking you, how could we use our calculator today to do it? So what would I do? Alpha, y equals again. Everything's from alpha, y equals. Which one do I need to go to now to go from improper to mixed number? 4 is fraction to decimal. 3 is going to take us back and forth, improper to mixed or mixed to improper. So 3 is what we want. And now notice we get our nice pretty 144 5/8. Okay? Definitely, I still expect you to be as smart as Jedi and be able to do it by hand. But I also want you to be smart with your technology when you get to the ACT. Okay? Any questions before I move my calculator? All right. So our answer here was what? Okay, and when I actually read my directions, what am I going to write down as my answer? 145 what? Miles. Okay. Quickly, let's go to the next one. And this is, you'll see questions just like this on your test. It says Lady Liberty holds a tablet in her left hand. The tablet is 7.19 meters long, 4.14 meters wide. If you made a scale drawing using the scale of 1 centimeter to 0.75 meters, what would be the dimensions to the nearest tenth? Now create the scale drawing. So we're going to try to figure out what would be the size, and then we're going to create it. So what kind of shape are we looking at here? Rectangle. And the actual tablet is 7.19 meters long and 4.14 meters wide. We want to create a scale drawing, literally with our ruler, an exact scale drawing. If this is our scale, 1 centimeter to 0.75 meters. How many dimensions do we need to convert? 2, a length and a width. So how many different proportions are we going to have to write? 2. If this was 3-dimensional and we had a length and a width and a height, how many different proportions would we have to do? 3. Don't try to use all the numbers at once. So start with just your length. Write your scale. Always start with your scale. What's the scale? Okay. Then plug in what you know and make sure you're putting it in the same location. So we know the length is 7.19 meters. Where does it go? Bottom. We're looking for the scale length, the scaled down length. So cross multiply. We have 0.75x equals 7.19. Divide by 0.75. I left out my units because I already know my units are going to be in what measurement? Centimeters. Okay, so what do we get? To the nearest tenth. So our length is approximately 9.6 centimeters. Okay, let's do the width real quick. Same exact process. We have 1 centimeter. Start with your scale. To 0.75 meters equals, this time, what's the width? 4.14 meters. And again, it goes in the bottom where the meters are. And we put x in the top because that's what we're looking for. Cross multiply. So we get 0.75x equals 4.14. Am I going too fast? Stop me if you have questions. Okay, divide by 0.75. And what is the width? Approximately 5.5 centimeters. Okay, create the scale drawing right now. Flip to the back of your notes. Take your ruler. You're not going to have room on the front. Go all the way to the back somewhere where you've got more room. I'm going to draw it on the board over here. You draw it on yours. We're going to compare. By the way, which side of the ruler am I going to use? The smaller one. The bigger one is in inches, the smaller one's in centimeters. How many millimeters are in a centimeter? 10. So notice that each of those little bitty marks is a tenth of a centimeter. Right? So when we're going to 9.6, we're going 9 and then 6 little marks past. Okay, create it on your paper. Label your picture with your units once you get it drawn. Does yours look different than mine? This is my favorite part. So what looks wrong with yours compared to mine? Looks super big, right? Okay, but look at the illusion. It's the perspective. It's really the exact same size. It's because it's on my big giant board versus your little paper. It's so cool. So it looks like you're doing it wrong, but you're really not. You did amazing. Sorry, there you go. That's right. All right, any questions? Scale drawings. Anybody not getting their picture to turn out? Not sure what to do? Okay, last thing, so we can be finished. This is one of the most important parts. Putting this all together and looking at some things that we notice here. Going back to what we've already learned. What is this called again? Similarity statement. What is this called? Similarity ratio. Similarity ratios compare corresponding sides. Would you agree that 3 to 6 is 1/2? 5 to 10? 4 to 8. Okay. What we have not talked about is what else has a relationship with our similarity ratio. So let's real quick look at the perimeter and the area of these two shapes. How do I find the perimeter of this triangle? Add them all up. What would I get? 3 plus 4 plus 5 is 12. Perimeter of this triangle, 6 plus 8 plus 10 is what? 24. Look what happens when you compare the ratio of the perimeters. 12 over 24 is what? 1/2. It is exactly the same as your similarity ratio. So if your shape is 2 times bigger, does it make sense that the perimeter then would be 2 times bigger? Okay. But notice that the ratio of the areas is not 1/2. Let's calculate the area again just to make sure we know how. How do you find the area of a triangle? 1/2 base times height, or base times height divided by 2. So that's 1/2 of what? Okay, but 3 and 4, which is half of 12, which is 6. Okay, let's do this triangle here. 1/2 base times height. What's the base? What's the base? 6. What's the height? And what's 6 times 8? Half of 48 is 24. Okay, I just wanted to review to make sure you could still remember from chapter 1 how to find area. Now look at what happens when you compare the areas. What's 6 over 24? 1/4. That is not 1/2. But 1/4 is 1/2 squared. If you square 1, you get 1. If you square 2, you get 4. So the relationship here is the ratio of the areas will be the same as the ratio of the sides squared, or the ratio of the perimeters squared. The next slide shows you this. If the similarity ratio is A to B, then the ratio of the perimeters is A to B, and the ratio of the areas will be A squared to B squared. Okay, what I'm going to ask you to be able to do is I'm going to give you a picture like this next example where they do not give you enough information to calculate the perimeter or the area. When you look at triangle QRS, there's a typo here. This should be an S. Fix that. Would you agree that you do not have enough information to find the perimeter of this triangle? Okay. Do you have enough information to find the area of this triangle? But I'm going to ask you to find the perimeter and the area. And the reason and the way you're going to do that is by using what we just learned about the ratio of the sides compared to the ratio of the perimeters compared to the ratio of the areas. And you're going to write proportions and you're going to solve. There's also another typo here. This should not be a colon. This should be a similarity symbol. Sorry about that. So LMN is similar to QRS. If two figures are similar, then what we just said is that the ratio, I would write this down to help myself, the ratio of the sides should be equal to the ratio of the perimeters. One half side to side, 1/2 perimeter to perimeter. So ratio of the side should be equal to the ratio of the perimeters. Therefore, you don't need to know all of the side lengths to find the perimeter if they're similar. They give me the perimeter of this triangle and they give me the area of this triangle, so I can just use that information. So first of all, let's start with the sides. What would be the ratio of the sides? 13 over 9.1. That should equal the ratio of the perimeters. What's the perimeter of the triangle with 13? 36. So we can find the perimeter of the other triangle. So now we're going to cross multiply and solve. And you'll see why we did that bell work of cross multiplying, because that's all you're doing today. So we have 13p equals, help me out, 36 times 9.1 is 327.6. And then we're going to divide that by 13. And the perimeter is 25.2. And what are the units? Centimeters. Okay? It's different for the area, so be really careful on the next part finding the area. I'm going to go to the whiteboard. So if you're watching the video, listen carefully. So now we're going to do the areas. But the rule is that the ratio of the areas are not equal to the ratio of the sides, but they are equal to the ratio of the sides what? Squared. The ratio of the areas will equal the ratio of the sides squared. So we'll start with your areas. What's the area of the first triangle? Careful, area. Area, 60. We don't know the area of the second triangle. That's what we're looking for, so we're going to put an A for area. The ratio of the areas should equal the ratio of the sides squared. So what's the first side? 13, but we're going to do what to 13? Square it. What's the other side? 9.1, but we're going to square it. Okay? And then we can just simply square those and cross multiply. 13 squared, I already know, is 169. 9.1 squared, that's what? 82.81. So we have 60 over A is equal to 169 over 82.81. Cross multiply. Get 169A equals what? 4,900? No. Is that right? 68.6. Take that, divide it by 169. What's the area? 29.4. What's the units? Centimeters squared. Make sure your area has units squared. Okay, the only thing I want to warn you about that's not in the notes, that will be on your homework, they may ask you to go backwards. So they may tell you something like this. You may want to write this down. They may say the ratio of the areas is equal to 81 over 4. And they may ask you, what's the ratio of the sides? So if the ratio of the areas is 81 to 4, what's the ratio of the sides? I heard somebody say it. What is it? 9 over 2. What did you do to get 9 over 2? Took the square root. Because you know that the ratio of the areas is supposed to be A squared to B squared, but the sides is supposed to be A to B. So we just need to take the square root of each one, and we end up with 9 over 2. If the ratio of the sides is 9 to 2, what's the ratio of the perimeters? 9 to 2, because they're the same. Do you think that they're going to give you nice, pretty whole numbers when you take the square roots? Not all the time. So if they don't simplify, that's it. Any questions? All right, you got about, I don't know, 15 minutes or so, 16?